Hello guys, let's do some more computation with sine and x in the denominator. So if we're talking about the limit x towards 0 for sine of x divided over x, you remember we proved it's equal to 1. So what is happening if we are having limit x towards infinity sine of x divided by x? Well, it's not that complicated. Think about it. Sine of x is never getting bigger than 1. X is going to infinity. So we're dividing at most 1 by infinity, so the result is, well, pretty fast, approaching 0. All right, what will happen if we're having limit x towards infinity of x times, well, sine of 1 divided by x? Now, let's think about it. We are having kind of sine of 0 here, and we are having infinity there. So do we see clearly what's going on? So we somehow are trying to kind of connect those two limits with each other. How can we do it? Well, let's do a substitution. Let's firstly rewrite the limit as a limit x towards infinity. And now look at this. We have a sine of 1 divided by x divided over 1 over x. All right. And now let's define u as 1 divided by x, and you see x and sine are both odd functions, so it doesn't matter whether we are approaching from the right hand side positive values or from the left hand side negative values. That's why we're saying, well, for the sake of argument, x is running towards plus infinity. We are having just u which is tending to 0. What I'm claiming is u is tending to 0. It doesn't matter from which side we're coming. So u must be running to 0, and what we're getting here is limit. We're having u towards 0 from the right hand side for sure. Sorry, you don't have to make any kind of cases here. And now we're having sine of u divided by u. And now you see, what is it about? This is 1 again. All right, so pretty nice proof. Just connect it. Now, what will happen if we have a limit x towards 0 of x times sine of 1 divided by x? You see the same what we previously had, but now we are having x towards 0, not towards infinity. What will happen here? Well, what we can do again, we may say, we'll try to do a substitution again. So let's call w equals to 1 divided by x. That means x is 1 divided by w, right? Now, x is running towards 0. This is where kind of problem could have, which I was approaching in the last example. Let's say x is positive, okay, for the sake of our, because we have the same plus or minus in sine and x, so it doesn't matter that much here. Let's see. So we're going to have a limit. W is approaching plus infinity. We are having x, which is 1 divided over w times the sine of w. And now you see what's happening. So actually it doesn't matter whether it's plus or minus infinity. Now you see it clearly here because it's about this value to become infinitely large. Sine is infinitely many times changing its sign, but we don't care because the result at the end is just 0. All right. So let us do maybe a few more. What will happen if we have sine of, let's say, 3x divided over x as x is approaching 0? Well, it's not quite sine of the same value, but we could multiply times 3 in the denominator and multiply times 3 in the numerator. So what we're getting is this limit is obviously 1, so we're getting 3. Pretty easy, right? What will happen if we have sine of x towards 0, sine of 5x divided over sine of 2x? What is happening here? Well, once again, we're missing x, right? But what we could do, we could rewrite it. Now look, I'm having limit x towards 0, I just write 1 divided by x over 1 divided by x, still sine of 5x divided over sine of 2x. I'm not changing anything, right? So now I'm having a limit x towards 0. Now look what's happening. We are having sine of 5x divided over x divided over sine of 2x divided over x. Well, that's getting better because we need now 5 here, which we write in the denominator, so we need to write it in the numerator. And now look at this, we need 2 in the denominator of the denominator. So what it means is we're actually multiplying times 2. So we should be, yeah, am I right? So I would be having it in, I would multiply times the reciprocal. So artificially make it twice as big, so I have to make it twice as small. So 5/2 now. And you see what's happening now? This value is 1 and this value is also 1. And now we just have 5/2. So basically what we proved, and it can be showed by every time you're doing so, if you have sine of alpha x divided over sine of beta x, the result is alpha divided over beta. All right? And let's do maybe one more example for today. We're just taking sine of, let's say, limit sine of pi x divided over sine of 3 pi x as x is approaching 0. And now you see what's happening. We proved it's the quotient between pi and 3 pi. So this is a third. All right? I hope it helped. Next time we're going to do a few more limits with the sine and maybe some more trigonometrical function. Thanks for watching, guys. See you in the next video. Bye-bye.